Welcome to today's lesson. In today's lesson, we are going to break down this ordinary differential equation and show that it is equals to this whole thing. We have been given conditions. They are saying when x is equal to 1 and y is equals to 6. These conditions are important for us to find this 42, which is the constant of integration. So let's dive in. Our solution. The first thing we need to do when we see an ordinary differential equation in this form, we need to check whether it's exact or if it's not exact. If it's exact, then we will solve it using the exact procedure of our differential equation. If not, then we'll need to find an integrating factor. So, for us to check if the ordinary differential equation is exact, this is what we need to do. We need to find the partial derivative of m of x with respect to y and the partial derivative of m of y with respect to x. So the function, when I say m of x is a function which is carrying dx, we have to differentiate this partially with respect to y. And this function which is going with the dy, that's n of y. We'll differentiate this partially with respect to x. So when we differentiate m of x, which is that function, with respect to y, we are going to get, for the first boy, we are going to get 3y squared minus, when we differentiate this part, we are going to get x. The third part, we are going to get x squared with respect to y, when we're differentiating it with respect to y. Then we have to say that it must be equal to whatever we're going to find when we differentiate n of y with respect to x. Now when you differentiate this first part with respect to x, we're going to find y squared. For the second part, it's going to be 2xy. Then the third part, I'm going to have minus 6x squared. Now we can try to compare and see if these two equations are the same. So we can see clearly from here, and for the question, sorry, there is a squared here, there is a squared there. So for this guy, it was going to be 2y. This was going to be 2y. It's going to be 2y. So we'll try to compare. We can see this part is same with this part, but this part and this part is different, and this part and this part is different. So when we see this, we can say that these are not equal, because if you can even just try and plug 1 for y and plug any numbers, even just plugging 1 for y and 1 for x, and see the answer that you are going to get. It's not going to be an equal answer, so they are not exact. So since we have proved that they are not exact, we need to find an integrating factor. We have to find an integrating factor, or we can use the other way around. First, we need to rearrange. What I mean by rearrange, we need to put them in a format like this one. We need to put them in a format like this one. We need to put them in a format which is similar to this. So for us to start, we can start by adding this n of y function dy both sides, so that it will go the other side. So in our the second step, what we are going to get is this y cubed x y squared minus x squared y minus 5x to the power 3 dx. All of this will be equal to, open bracket, x y squared minus x squared minus y minus 2x cubed dy. Now since we have this and we want to put it into this form, which is dy over dx, we can divide throughout dx, so that dx will, when we divide throughout by dx, we can see that this dx and dx will cancel, and we are going to have dx at this side. So now, since we have dx, dy dx, and we just want to leave it alone, we are going to divide this whole thing, both sides, so that it cancels here. So what we are going to have as our final function for us to deal with is dy dx is equal to y cubed minus x y squared minus x squared y minus 5x cubed over xy squared minus x squared y minus 2x cubed. So now, ladies and gentlemen, this what we have here is the function we are going to work with. So for us to start here, we can say, what we can say is, let v equal to y over x. Now, what is y in this case? Y in this case will be v over x. The main instance of us doing this, we want to change our main function into another function. Because try to look at this, you can't separate it. You can't separate because they are all jumbled up. So I want to introduce a new function which will replace our main function, which is y, and make this function, this whole equation, separable. Once we can separate it, we can integrate it. Then afterwards, we'll put back our main function as it was. So first thing first, we need to eliminate dy. So look at our function we have, which is y is equals to vx. You can put any letter of your choice. It could be u, it could be j, it could be any letter you think of. So whatever you just need to maintain is your main function, which is y, and the baby function, which is what? X. So when we differentiate this equation with respect to y, with respect to x, this is going to be dy dx equal to, this is product. So when we differentiate, we're going to differentiate first v with respect to x, which is going to be dv dx multiplied by this x, then plus we add when we are differentiating x with respect to x, which is just going to be x multiplied, which is just going to be 1, then 1 multiplied by v, we're going to have what? We're going to have v. So x multiplied by dv over dx plus v is the same as dy. So we are going to replace this where there is dy, so that we eliminate dy and introduce dv as our new main function. Now look at this, y is equals to vx. So wherever you are seeing y here, we're going to replace it with vx. So let's write that next step. Dv, I'll write x in front, dv dx plus v is equal to, where there is y, I'm going to be putting vx. So this will be v cubed x cubed minus, this will be x, then where there is y, this will be v squared y squared x squared. For the third part, this is x squared, where there is y, I'm going to put v x minus 5x cubed. Then this is all over x, where there is y, I'm going to put vx. Then we subtract x squared, where there is y, vx. Subtract 2x cubed. Now we are going to simplify by multiplying these brackets. So I'm going to write everything the way it is, x dv dx plus v. This is equal to v cubed x cubed minus v squared x cubed minus v x cubed minus 5x cubed, this to be all over x cubed v squared minus x cubed v minus 2x cubed. Now from here we can identify that this term as x cubed, this term as x cubed, the same for this. It is the same situation for all of those. So what we can do is we can factor out x cubed. When we factor out x cubed on the top and on the bottom, they are going to cancel each other. So what we are going to have on top is v cubed minus v squared minus v minus 5. At the bottom is going to be v squared minus v minus 2. So let's write that. Now we can cancel out the x cubed after factoring them out. So our equation would turn out into this form. This is what we have. This is what we have finally. This is what we have found. So now look at this. We have dv and we have v functions here. We have dx and we have an x function. And in this form, we can separate it into this form, which is it has become in. It is now separable. So the first thing we are going to do is we are going to subtract v both sides, so that this v goes the other side. We just remain with x dv over dx. So this is going to be x dv over dx equal to v cubed minus v squared minus v minus 5 over v squared minus v minus 2, then minus v. So now from here, the next step is we need to simplify what we have here. So what we are going to do, what we are going to have, the left side is going to remain the same, dv over dx. For this one, I'm going to make it all over the same denominator, which is v squared minus v minus 2. So when v squared divided by v squared is 1, multiplied by that whole thing on top, we're going to get it all. V cubed minus v squared minus v minus 5. But be reminded, this v is v over 1. So when we say 1, the denominator for v, 1 divided by this is the same thing. So I'm going to say minus v, 1 divided by the denominator is the same denominator. Then the denominator multiplied by v. Like the same thing we did, this divided by this, what we find? Multiplied by this. So here we got the 1. 1 multiplied, we got this. For this one, we're getting the whole thing. Multiplied by v, then we're going to multiply it by v. So this is v squared minus v minus 2. This is where we are now. From here, we can continue. We can expand and then cancel those who are going to cancel and see what we are going to have. So for this one, we're going to have v cubed minus v squared minus v minus 5. So negative v multiplied by v squared is going to be negative v cubed. Negative v multiplied by negative v is going to be v squared. Negative v multiplied by negative 2 is going to be positive 2v. Then all over the same denominator, which is v squared minus v minus 2. Then from here, we can try to find those terms which are cancelling out. This one and this one, they are going out. V squared, also v squared, it's going out because it's v cubed minus v cubed. V negative v squared plus v squared is cancelling. Then we can see here 2v minus v, that is the same as v. So on top we are going to have v minus 5. So this is x dv dx equal to v minus 5 over v squared minus v minus 2. Now from here, we need to put this function into a form where we have the function of v on the same side with the dv, and the function of x, which is x, on the same side with the dx. So let's take dx to the right side and leave dv at the right side, the main function. So this is going to be dv x equal to v minus 5 over v squared minus v minus 2, like this. Then dx, we have just cross multiplied. You can just multiply the whole function with dx. So for us to take this where there is dv and to take x where there is dx, for this one we just need to multiply by its reciprocal. So we can multiply this with the v squared minus v minus 2 divided by v over 5. Everything will cancel out. For this one, for us to remove x from this side to the right side, we just need to multiply by 1 over x, which is a reciprocal as well. So what we are going to have finally is v squared minus v minus 2 over v minus 5. This, it will be what? Dv equal to 1 over x dx. Now in this form, we can integrate. Now for this one, it is direct. We know this is going to give us the natural log of x. Now where there is a tricky part, it's for this one. You can see that the numerator has a v with a higher degree than the denominator. What does that click in our mind? Polynomial division before integration. So we have to divide. This will become our dividend and this will be our what? Our divisor. So we can use polynomial division for this one so that we make our integration which we need. This is 5 v minus 5. This is v minus 5. This will be v squared minus v minus 2. So the first thing is first, we'll divide this dividend until we get our dividend to have a v with a lower degree than the v in our what? In our divisor. So v divided by v squared, we're going to get what? We're going to get v. Then v multiplied by v. This is what? V squared. Then v multiplied by negative 5. This is negative 5v. Then we are going to subtract the whole thing the way it is. I'm going to put it in bracket and say minus. Then v squared minus v squared. Here I'm going to get a 0. Now minus v minus 5v. This will become a positive. So it's the same as 5 minus 1, because here the coefficient here is 1. So 5v minus v is the same as what? This will be plus 4v. Now again we divide v. V divided by what? 4v. And again let's drop down there. Let's drop down this side. Can drop down. This will be negative 2. So v divided by 4v, we are going to get plus 4. Then 4. Now we are not multiplying using v. We are multiplying using the answer we found. 4 multiplied by v, we are going to get 4v. 4v. Then 4 multiplied by negative 5. 4 multiplied by negative 5. This will be negative 20. This will be negative 20. So we're subtracting the whole lot of this. So negative 4v plus 4v. So it's the same as 4v minus 4v, which is what? Which is 0. Then negative 2 minus 20. So this will be what? Positive. So it's 20 minus 2, which is the same as what? 18. Now, can v be divided into 18. We have found that now our dividend has a v with a lower degree, because this is v to the power 0, which is just 1. So now this is how we are going to write our answer, how we are going to represent our answer for this. We are going to get our answer on top, which is v plus 4. Then our remainder, this is plus. If it was minus, we're going to say minus, but it's plus, so it's plus 18. Now our remainder will be over our divisor, because this is still dividing in this, isn't it? So this will be 5 minus 5, v minus 5. Then this is dv. This is dv equal to 1 over x dx. Now look at this. We have to integrate this side and we have to integrate this other side. So for this now it's simplified, because we can integrate term by term. We can integrate v, we can integrate 4 with respect to v as well, because it's dv. Then we can also integrate this guy with respect to v. And we can integrate this side with respect to x. Then we see, we'll try and compare with what we're given the question for us to follow. So let's integrate this term by term. This will be the integral of v plus the integral of 4 plus the integral of 18 over v minus 5, all equal to the integral of 1 over x. This is dv, this is dv as well, this is dv, then this is dx. Now when we integrate v with respect to v, it's more like when we integrate x. So this is going to be v 1 plus 1, which is 2, then divide by the new power, which is 2. Then plus, when you integrate a constant with respect to a letter, which is v, we're going to produce the same constant accompanied with the same letter. Then plus. Now, look at this, what we have here. I'm going to factor out the 18 outside. And for this boy here, we are going to say, we just need to ask ourselves one question. Is the denominator going to be the derivative on top when we factor out 18? Because see how it's going to turn out to be. It's coming out like this. So the question is, when you find the derivative of the denominator, is it going to be equal to 1? Yes. When we differentiate v minus 5, it will give us 1. So with that being said, look at this, 1 over x. When we differentiate x, we're going to get 1. So the answer is going to be ln v minus 5. Then equal to, this other side is the same thing, ln of x plus c. Now from here, and again, you can use u sub for this one so that it makes more sense. You can use u substitution so that it will make more sense. Now from here, we need to ask ourselves one question. What was v? What was v? So v was equal to y over x. Now this is v squared, so this implies that it's y over y squared over 2x squared plus 4. Now there it's v, we're going to replace it with y over x plus 18 ln of, where there is v, I put 1 over x minus 5 equal to ln x plus c. Now whatever is in this brackets can be simplified further as well. We can just make one denominator as x, then we say x into x, it's 1. 1 multiplied by y, it's 5, is y. Then 1 divided by x, it's x. X multiplied by 5, that will be negative 5x. That's what we have. This is what we are going to have in the brackets. So we can write everything else the way it was. We can just write everything else the way it was, plus y squared over 2x squared, then this is all equal to natural log of x plus c. Now this is where our conditions come in handy. We were told that x is equal to 1 and y was equal to what? 6. So wherever there is x, I'm going to put 1, and wherever there is y, I'm going to put what? I'm going to put 6. So the whole instance of this, we need to find this integrating factor, and we pray to God it needs to be 42 as the thing we are, as the answer in the question we were given. So let's go ahead and substitute. Where there's y, I'm putting 6. Where there's x, I'm putting 1. So this is 1 squared. So 1 squared is 1. 1 multiplied by 2 is going to be 2. So I'm just going to leave a 2 at the bottom. Plus, this will be 4 multiplied by 6 divided by 1. I'll just leave it the way it is. Plus 18 natural log of 6 minus 5 multiplied by 1 is the same, divided by 1 is the same. This is equal to the natural log of 1 plus c. Now look at this. The natural log of 1 is 0. So this part will go. The natural log of 6 minus 5, which is just 1, it's 0. So this whole term as well will go. Now our main attention is, our main interest is to this. So what is 6 squared? 6 squared, it is 6 squared. You can use our calculators. 6 squared. 6 squared is 36. 36 divided by 2, that's 18. So 6 squared divided by 2, it's 18. Then 4 multiplied by 6, it is 24. Plus 0 equal to 0 plus c. So now we can just say c is equal to 18 plus 24. 18 plus 24, which is what? Which is 42. Now from here, since we have identified c to be 42, we can write the whole equation the way it is and replace c with 42. So our equation is y squared over 2x squared plus 4y over x plus 18 natural log of y minus 5x over x, all equal to ln of x plus 42. Now let's try to compare what we were given in the question. Look at what we were given as the answer in the question. Y squared over 2x squared plus 4y plus 18 natural log of y minus 5x over x equal to natural log of x plus 42. It is what we have found as well. So from here we can just say hence shown. Thank you for watching, and please, if you haven't yet hit that subscribe button, you can hit it and click on the bell icon so that you don't miss out on future endeavors. Thank you.